All right, today we're going to talk about the concept of absolute value. Absolute value is notated in mathematics with two bars around some sort of an expression. So you might see the absolute value of just a number, such as -3, or the absolute value of 4, or maybe it's the absolute value of x plus 2. But that's how we're going to notate absolute value. Absolute value, it's really important. Most people think of the fact that absolute value means positive, and you're correct in that thinking, but the reason that we think about it as positive is because the absolute value actually is talking about a distance, and we travel in positive distances when you think about geometry and measuring. Okay, you can have negative direction, but we always have positive when we talk about distance. So officially, absolute value is the distance between the origin, so that point 0, 0, or 0 on a number line, and the number itself. So distance, distance, distance. All right, so a couple of applications of absolute value. If we think about a real-world situation, the temperature in Chicago was a certain value last night at midnight, then 87 degrees at noon today. Write an equation to represent the change in temperature over a 12-hour period. So first of all, we're looking to write an equation, which means I know I'm going to need an equals sign. We are talking about a certain value, but we don't know what that certain value is. And so when we have an unknown in mathematics, we're going to call that certain value x. But we're talking about the change in temperature in relation to 87 degrees. So if you think about how things change, we have a couple different mathematical options to pick from, right? We have operations of addition, subtraction, multiplication, division, exponents, roots, all those good things. But if we talk about the change in temperature, the best way to go about figuring out change is to think about subtraction, right? So if somebody has 80 things and someone else has 70 things to represent the change from 70 to 80, you would subtract 80 minus 70 or 70 minus 80, and you would get 10 or -10 respectively, right? But that represents the change. So another way to think about distance is to also consider the word difference. Difference between where you started and where you ended up. So distance, difference, and we know that difference in mathematics means subtraction. So all these things are kind of intertwined. So going back to our problem, we want to talk about the change between our certain value, which we said was x, and our 87 degrees that was provided for us. So there's our difference, right? And that represents our change. Well, we don't really know if it was warmer at midnight or cooler at midnight in comparison with the 87. We don't really need to have that information, right? It's not asking us, did the temperature rise, did the temperature fall, anything of that sort. We just want the change. We want the distance, we want the difference. So we're going to put some absolute value bars around this difference, because if x was bigger than 87, let's say it was 90 degrees at midnight, well, then it had a change of 3 degrees. If x had been smaller than 87, let's say it had been 85, then it had a change of 2 degrees. Doesn't matter, we're not talking about an increase or a decrease, we just want to talk about the change, in which case distance, and we're using our absolute value bars. Also, it's a video about absolute value, so it makes sense that we use absolute value for it. Alright, so let's talk this time. We're going to set up the distance between x and -10 is at least 6. So I'm going to point some important things out to you. First of all, we've got this word distance again, which should indicate difference, and then we want to take absolute value. But then we have this at least. So we're not talking about an equation necessarily. We're talking about the least value that it can be is 6. So take a second and kind of think about, what does it mean if 6 is the lowest or least value that an expression could be equal to? And how might you write that? Instead of an equation, what would you use instead? So go ahead and pause the video and think for a second. Hopefully you thought back to our video from last night about inequalities, and if 6 is our lowest number, then instead of an equal sign, we're going to use some sort of a greater than or less than, greater than or equal to, less than or equal to symbol instead of an equal sign. So I'm going to ask you again to pause the video and unpause it when you are ready to check your work, or if you get stuck, but see if you can write an inequality for the distance between x and negative 10 is at least 6. All right, so if we follow what we did on the last example, the distance between, distance is difference, so the distance between x and negative 10, okay, we got those absolute value bars because we're talking about a distance, so it's always positive, is at least 6, which means 6 is the smallest that it can be, so we want everything bigger than or equal to 6. While cleaning up some double subtraction, I put in the addition sign. So yes, this is an okay answer, but you should be able to clean up and make that into addition instead. The other way to do it is to talk about negative 10 first. So the distance, again, we've got subtraction and those absolute value bars. The distance between negative 10 and x is at least 6. So greater than or equal to 6. It helps if you really think about setting up the structure like this, and then we've got something over here, and this is either going to be greater than or equal to, greater than, less than or equal to, less than, or equal to. Okay, right? That's how we're kind of setting up these different equations and inequalities. All right, let A be any real number. We've talked before about real numbers. Okay, so rationals and irrationals. Explain how it could be true that the absolute value of A is equal to negative A. So, first of all, it is true, right? I'm telling you it could be true. And there's actually two different ways. A hint for you is instead of thinking about it as negative A, consider it to be the opposite of A. Right? That negative sign means multiply by negative 1 makes it the opposite. So I want you to pause the video and unpause it after you have come up with one, maybe even both ways that this statement would be true. And you can unpause it if you get stuck or whenever you're ready to check your answer. Alright, so the two ways that this can be true is first, if A is equal to 0. Well, then the absolute value of 0 is equal to negative 0, and negative 0 is just 0. This is a true statement. The second way is if A is a negative number. So for instance, I picked negative 3. So I'm going to take the absolute value of negative 3, right, just plugged in for A, is equal to the opposite of A itself. So the opposite of A, which was negative 3, well, negative negative makes a positive, and the absolute value of negative 3 is equal to 3. So again, important things to remember about absolute value. Think distance, which sets up the difference. So subtraction is what you're going to want to use. And make sure you're paying close attention to words like at least, or at most, or equal to.